Next, I'm going to introduce you the exact mathematical operation on how the double integration can be implemented. So just now we introduced a lot of concepts. For example, the first moment of inertia is the integral of y over the entire region if we are talking about x-axis, etc. So there are a lot of formula, but how can we actually implement the double integration method to solve the area moment of inertia? So let's try to deal with this example first. So this is an example, okay? It is not something that you have to remember, but the example will in this example I will demonstrate to you how to find the moment of inertia by using the double integral. So it is relevant to one of your previous course, which is Math 2011 multivariable calculus, and I wish to use this example to let you do some basic review on it. So, what is the area of this rectangle? Well, area of the rectangle equals to the integral of all the area elements of all the area. It sounds that I am saying something like rubbish. Yes, the area is the integral, is the summation of all area elements, but this is how we use the double integral to evaluate the area. We know that for x-axis, the bound is from -1 to 5, while for the y-axis, the bound is from -1 to 4. Therefore, the area of the rectangle equals to the integral from -1 to 4, integral from -1 to 5, and nothing inside means 1, okay? So we often ignore it. For -1 to 5, it is talking about dx, and for -1 to 4, it is talking about dy. The result will become 30, which is significant. Because, so in case you don't understand why it is 30, so -1 to 4, -1 to 5, dx, dy. First, we integrate with respect to dx. Then it will become -1 to 4. X is integrated from -1 to 5, and then dy. Then you know this piece of stuff will equals to 6. Then it becomes 6 times -1 to 4 dy. It equals to 6 times y from -1 to 4, which is 6 times 5 equals to 30. Next, let's try to find the first moment of inertia about the x-axis, that is qx equals to the double integral of the entire area y dA equals to -1 to 4, -1 to 5, y dx dy. How to do this double integral? -1 to 4, -1 to 5, y dx dy. First, for the inner integral, you can see that it is so y is irrelevant to x. So you just treat y to be the constant, -1 to 4, take out the y, and you do the integral -1 to 5 dx. And as what we just said just now, this thing is just equals to 6. And you have the dy behind. Then it will become 6 times -1 to 4 y dy. And you know, after you integrate y dy, you will obtain 6 divided by 2, because y is going to be y squared, and you will have a denominator developed. So it is y squared. Then the upper and lower limits are still -1 to 4. It equals to 3 times 16 minus 1 equals to 45. Therefore, we know that the first moment of inertia about x-axis is 45 for this rectangular region. Next, talking about the first moment of inertia about y-axis, Qy equals to the double integral of the entire region x dA equals to integral from -1 to 4, integral from -1 to 5, x dx dy. Well, how to do this integral? First, -1 to 4, -1 to 5, x dx dy. You can see that the inner integral is relevant to x, so therefore we will integrate it, and consequently there will be 1/2 generated from the integration. And for the x squared, you have 5 minus 1, and you know this is just a number which is 25 minus 1 equals to 24. So this is 24 dy. And then you just take out the number, it is 12 times -1 to 4 dy, and significantly it equals to 5. Therefore, it is 12 times 5 equals to 60. Therefore, the first moment of inertia about the y-axis is 60. Let's accelerate a little bit, because all the things we are doing currently is just to do the double integral again and again. For ixx equals to the double integral of the entire area y squared dA equals to -1 to 4 -1 to 5 y squared dx dy. So we copy it here. -1 to 4 -1 to 5 y squared dx dy equals to 6 times -1 to 4 y squared dy equals to 2 times y cubed. 4 minus 1 equals to 2 times 64 plus 1 equals to 130. Iyy equals to the double integral of the entire area x squared dA equals to -1 to 4 -1 to 5 x squared dx dy -1 to 4 -1 to 5 x squared dx dy equals to 5 times 5 divided by 3 x cubed from -1 to 5 equals to 5 over 3, 126 equals to 210. So bear in mind that I have already accelerated my calculation here, so try to follow it, try to integrate yourself. And finally, Ixy equals to the double integral of the entire region xy dA equals to -1 to 4 -1 to 5 xy dx dy. So in this case, bear in mind that it is a little bit complicated, because xy is sticked together. There are two variables. Therefore, Now let's do this. -1 to 4, -1 to 5, xy dx dy. So since the inner integral is integrating with respect to x, then y is the constant. Take the y out, and for the inner integral it becomes -1 to 5 x dx. Then you have dy outside. You know that the value will become -1 to 4. So you know that since this piece of stuff, after evaluating it, will become a constant. Therefore, you just take it out. The entire integral will become something like -1 to 5 x dx times -1 to 4 y dy. Okay. Then it will become 1/2 x squared from -1 to 5 times 1/2 y squared from -1 to 4 equals to 1/4 25 minus 1 and 16 minus 1 equals to 6 times 15 equals to 90. So the second moment of inertia Ixy about the origin is 90. Well, let's discuss a little bit more. So for this second moment of inertia, why it is non-zero? It is because it is neither symmetrical about the y-axis. It is not, right? Y is not the axis of symmetrical. It is neither symmetrical about the y-axis nor symmetrical about the x-axis. Therefore, it will be non-zero.